Hello everybody, and welcome to example 5 on page 103 of the workbook. This is another example of calculating a definite integral using the fundamental theorem of calculus. So let's work through this problem together. We are being given an integral that looks like integral of x times x plus 1 dx. Okay, and we've talked before in previous examples about how the key here is being able to find an antiderivative for the function that we're integrating. There's a little difficulty though in this problem that we haven't encountered before. Notice that we've got a product x times x plus 1, and we have a product rule for derivatives but not for antiderivatives, and so this function is not in a form right now where we can take an antiderivative easily. So what we need to do here is to do a little bit of algebra before we find an antiderivative. All right, so we can take that x and distribute it through and rewrite this as x squared plus x. And now, because we've got a sum of two functions, x squared plus x, now we really can take the antiderivative term by term here. All right, so we could start with the x squared. What's an antiderivative of x squared? Well, that's a power of x. So if you look back at the table of antiderivatives, that was the power rule, the very first formula. We just need to take that power of 2, raise it by 1, and divide by the new power. So we're going to get x cubed over 3 for our antiderivative. And then x is x to the first. Use the power rule on that, and we're going to get x squared over 2. We raise that power by 1 and divide it by 2. Okay, so our antiderivative is x cubed over 3 plus x squared over 2. Now we need to evaluate that between 1 and 0 to get our integral value. Okay, so we'll start by substituting in the upper limit. So 1 cubed over 3 plus 1 squared over 2. There's the upper limit minus the lower limit, 0 cubed over 3 plus 0 squared over 2. Okay, and you might notice that these two terms over here, those are just going to both be 0, so they go away entirely. And what we're left with is just 1/3 plus 1/2 when we do the arithmetic here. Okay, and if you add those fractions, get a common denominator, we are going to get an answer of 5/6. There is the value of our integral.